Okay, so hello friends. Today we will see how we can create now a binary tree, and based on that how we can perform a recursive pre-order traversal. So that is our main motto today. So I will just write here recursive pre-order. First thing we have to see. So how we can perform? So for understanding this, first we should see how we can create a node. So node creation we have seen in the last video. If you could not see that, so please go and see that first. Before that, you cannot understand this one. So for node we require data. Okay, we require some pointers left and right. Okay, this thing should be public so that it will be accessible. Apart from this, what do we require? We require again constructor, this constructor. Okay, I will not talk much about this in detail because this has been covered into previous video. Okay, so now we will go for next thing, that is for actual creation. So for creation or for taking the input, we will use one function. Let's say that is a create function. You can write any name, it's not mandatory. Okay, so this function is again the kind of pointer type because it will hold the address of your node. So this is the pointer function, and now in this function I am just as of now creating a node pointer. So I will just write here node star put. This is the like pointer I have created. Then I'm asking the user to enter some data for node. So I'm just writing here cout enter data like this, and I'm storing the data into X. This is the like basic thing you can understand. Okay. Apart from this, what we will check, like the data can be anything from the user. Let's say the data is 5, 6, 7, 8. Any data you can provide. It can be anything like any data you can provide, but at a some instance if you are providing data, let's say 0 or let's say some -1 -2, so that case we should have the assumption like it's an invalid node. It's telling to the machine like that node is invalid, it's a null value. Means for that data input you should not create any new node or any new child. So what I will do, I will simply write here if that x is what, let's say -1, then it should return nothing. So it should return what? It should return null. Nothing means null. Okay. So here user will ask or user will provide any data from his requirement. But what if he will provide -1? So in that case, no new node should be created. But if this condition is true, sorry, if this condition is false, so in that case, a new node should be created. So how will you create a new node? We have already defined a pointer. For that pointer, I will create now a new node. So root equals to new node. Okay, and what at value it will hold? It will hold that same data which you have passed. Okay, so you will pass here that x. Okay, I hope you understood this. So first what we are doing, we are asking the user to enter data. It will be stored into that x. After that you will check the condition. If that x is -1, you will return null. Means the new node will be null. Okay. But if you are providing any other value apart from -1, so new node will be created. That's it. And after that, for that new node, you can again ask what is the left and right child of that node. So you can say enter left of your x. This thing you can ask. Okay. And also you can ask again enter what we can say right of that x. Okay, so whatever the x you are creating as the new node, We are asking its left child and its right child here, both the things we are asking. So let's say if you are asking left child, should be stored where? Left child आपका कहाँ पे जाना चाहिए? Left node यानी आपके root के left में जाना चाहिए. That should be your assumption. So here, if you are considering a new node, so new node or the left child of that node should be treated as the roots left. Why you should consider roots left? Because we have considered here left pointer will be hold the address of that left child. Okay. So here what I will write roots left will hold what? That left child. And if it's holding that left child, so again that left child's data should be asked. So we have asked here data, we are creating here the node. If that new node is, let's say, providing the value -1, so it will say the new node is null. So this complete process should be repeated. So what you can do, you can simply again call this function inside its own body. So this is recursion, we can say, like inside the same function body, we are calling that function itself. So this is a recursive call. Okay, so hence we are calling this is what? A kind of recursive pre-order traversal. Okay. Also we will again see like when we are again using this recursive call. So here again, if you are calling the right child, so again it will be stored toward roots right. Okay. Again, you will call the same function, that is create. Whenever we will go with the example, you will understand more precisely. So that's all the process. After this, ultimately it will return root. That's it. This is what this is your just a create function. I hope you understood this. Next thing is what now you should print those nodes. So how you can print? You can simply again create one pre-order function. Okay. So pre-order function again takes your root. So I will simply consider here node star root as the argument, because if you want to traverse something, so definitely you should pass those node थ्रू दिस फंक्शन. आपको इन्हीं नोड को प्रिंट करना है. इट शुड बी कमिंग टूवर्ड्स योर आउटपुट, सो you can pass them to as an argument here. So here also you can provide a condition check. That condition check is really important. If you can say the node is not equal to null, or if your root is not equal to null, then only you should print. If you will just ignore this condition, then your outcome might or your output might come continuously. Okay, so you should just keep this condition precisely first. If root is not equal to what? Null, then only what you should do, then only you should first print your root. So root is what? Root is your actual data. So we know that into our pre-order traversal, how do we print? So here pre-order traversal, pre-order traversal, pre-order order again traversal. So if I will go here, I will show you some kind of diagram like into this tree, or into previous diagram somewhere the traversal was present. Yes, this was. Okay, it's not looking proper. Can we use this? Yes, we can use this one. So here into this diagram, you can see how the pre-order traversal looks. So just let me open this. Here you can see in this diagram for pre-order traversal. What do we print first? This second is pre-order. If this is the tree with the root 1, so we are first printing the root only, then we are printing left child, and then we are thinking for right child. This is our pre-order traversal. So here also we should first print the root. So what I will do is I will simply first write here cout. I require some space. I will simply say roots what data, because data is holding your actual nodes data. You have mentioned here data. Okay, all the things which are passing to or through this create function is moving toward what is moving considered as here a new node, though you are passing. So if you are creating any object, so while creating the object, ultimately this constructor will be called. So constructor, if you are calling, so this x will be passed here and it will be stored into data. That's why You are printing first what you are printing roots data. Next thing you are now calling again pre-order function. Into pre-order function, after printing data you should go towards the left side of your tree. So what I will do, I will say roots left I should get. Okay, and again recursively I will call pre-order, and I will say now I require roots right. So how does it work, we will see with the example. Okay, so as of now just keep it as it is. I will tell you whenever we will execute this code. Okay, so this is just like the recursive call of the function, like inside the same function body we are calling the function itself. This is again recursive call. Then I will go for the main function. Into this main, what we require now something as we can consider what we require. Okay, we can create here node pointer. So I will use node star root equal to, I can call create, and I can again call that pre-order function. Okay, first I have called create function by using pointer, and I have passed now the root into pre-order function. So we will see whether it works or not. Okay, we are getting some error. Okay, it's telling iostream. So iostream, the spelling was wrong. Okay, so I hope we should get now something. IOSTREAM. Okay, stream STREAM. Okay, so now it worked. So this is like the enter data. Okay, so now how the program works we will see. So for that I require paint here. So into paint, let's say now what it's asking, it's now asking me enter data. So what I will do is I will pass here something. I'm passing here, let's say some 5. Okay, just let me increase the size. It's a 72, not a 72 required, it's 36. Okay, so this is 36 as the size. Now if I will enter here 5, so what will happen? Initially what is happening now, we have called here create function. Okay, so what is happening through the create function, we are passing the data. Like with this statement we are passing here 5. Okay, so I have entered 5. So what it's asking me now, entered left of 5. Left of 5 means after entering this data, this statement's executed. It checked whether that x is -1. Yes, it was not a -1, so this statement became false. And now this statement execute like root is equal to new node. So new node is created with value 5. Okay, and after that, sorry, new node was created here, that was 5. And after that what statement execute, enter left of 5. This statement was executed, enter left of x. And after that it's again asking this enter data. Why it came, because by using this now variable, that is root of left, we have called create function again. So inside this create body, again this statements executed. Like we have again created a pointer, root pointer, we have again declared the same variable x. We are asking now enter data. So let's say now I will again enter new data. That new data is now, let's say 4. Okay, what I will do is I will enter here 4. Again the size is here. Now let's say a little bit, how we can say the size is here. Okay, this is the size. So the new data is here, let's say this one. Okay, okay, this is the new data 4. So you are entering now 4. So what will happen, if you are entering 4, so again it's asking what, it's asking now again enter left of 4. So what is happening here, again we stopped here only. Okay, the new statement was came like enter left of 4, and again as you entered 4, it's asking again left of 4. So again we are here only. Okay, so this statement was executed, again it's asking enter left of 4. So this statement came. So let's say now I don't want to add any new node. So what I will add here, I will say this x will be what? Minus 1. So I will add here minus 1. So what will happen if I will add a minus 1? So now it's asking me enter right of 4. So how now the things are changing, you can check. First, the 5 was executed. Okay, we have done the 5 as your first node. 5 we have done. Then it's asked what is the left of that 5. So we told it's 4. Okay, then it asked me what is the left of that 4. So I said it's minus 1. It was what? Minus 1. Then it asked me what is the right of 4. So I said it's minus 1. So minus 1 means what? That is null. So null values we have provided means we are not expecting now new childs. So here this control now stop. Okay, they are stopped here. Now the control will go here at the up. Okay, so here what are the next statements? You can say after the right it's returning the root. Okay, it's returning your node. So returning node means it's now creating a relation in between these two. Now the relation has been established. Like this was your initial root and this was the new root. 5 was the initial root and 4 was the new root. So 4 and 5, how they are related? 4 is 5's left child. Okay. And now the control is came where? Control came here. If you are now entering here, let's say this as minus 1. So the control is coming here. Enter right of 5. Okay. So right of 5 can be what? Right of 5 you can provide anything. If you will say now right of 5 is what? That is, let's say here, anything, let's say 7. Okay. So again, let me increase the size. 7. Okay. So after this 7, what questions you should get or how the statements will execute? It's again asking what is the right of 5. So I will, let's say 7. So again it asks me like enter the left of 7. So how the things are changing? If you are entering data as 7, so it's stored here into x. It check whether the 7 is minus 1. No. So this statement not executed. Then the new node became with the size 7. Okay, so that 7 is passed here inside this one, and data became what? Data became now 7. Okay, but now it's asking enter left of that 7. 7 का लेफ्ट क्या देना है आपको? So what if I will again say this is what? This is minus 1. This is minus 1. Okay, so now the control came here for the next statement, enter right of 7. So again, what if I will say this is also minus 1? So what will happen at this instance? आपने क्या किया? Now you have provided this one also minus 1. Left is also minus 1, right is also minus 1. So we know that how the 7 and 5 are related. Somewhere we have created the relation in between them. How you got the 7? You told uh, enter right of 5, then you inserted 7. So right of 5 means this was the statement which executed. Right of 5, when the x was 5, then this statement was executed. At that time the x new node was what? It was 7. So 7 you have provided. Then for 7 the left and right child both were minus 1, means no new node is created. So now they are related like this, like this. Okay, so you got the tree like this, and ultimately what will happen? Ultimately, it will return the root. Okay, so if you will return the root, so what you should get? You should get here this kind of result. This is what? 5, 4, and 7. So 5 is what? 5 is your root, then 4, and then 7. So you got this pattern. This is 5, then 4, then 7. So we will again increase this size. 547, this statement you got, or this pattern you got. Okay, so how it came? For this we have used a different function, that is preorder. So into preorder we checked first condition, that was what? If root is not equal to null, we checked what was the root. Root is here 5. 5, is it a null? No, it's not null. So what you will do, you will simply print roots data. Roots data is what? Roots data, this is what 5. That's why 5 printed here. I hope you are understanding how the 5 is printed. Okay, only this one printed. Then next, what we have done? We have done here this recursive call. So we move toward roots left. So what was roots left? If you will again go to this roots left, so roots left is this 4. Okay, and after that again this statement will execute. Roots left, if you will consider, so again if you will print that, so what you will get, you will get that data to be printed. So roots left is 4, so it should be printed. You are calling this function where into preorder, right? Roots left, you are calling where by preorder, and preorder is what? Preorder is asking again what is roots left. Roots left is 4. You can see this is 4. Okay, is it a 4 can be treated as null? 4 is not a null. So what you will do, you will print that. That's why you got a next node 4. Okay, I hope you understanding this. Then again you are calling roots right by using same preorder function. So if you will pass roots right, so the value will become what here? 7. Okay, and again you will check whether the 7 is a null. It's not null. That's why what will happen, again you will check if it's not null, so simply print that data. So here the 7 will be printed like this. I hope you understood this. So this was what? This was just a simple, we can say, binary trees pre-order traversal in recursive way. Okay, so I hope you understood this. So in next video, we will try to go for in-order and post-order traversal. The things will be completely same, only few changes we will do. Okay, so please practice on this code. Surely you will understand. If you face any queries, please come to me. Okay, thank you.